Hello, my name is Emile Yamaki. I work for Red Hat. Um, I would like to make a presentation of the operational tools in TripleO. Um, so I have some slides to explain exactly what I would like to present today. I also have a demo, but the Puppet run is taking some time to deploy the stack, so I will just run the Puppet right now, and I will present the slides in the meantime so we can see the result at the end of the presentation. So, what are the operational tools? Um, there is two things right now, the event monitoring and the centralized logging. For the event monitoring, I propose to use the Sensu, which is an open source framework to collect and analyze the custom metrics. It's also monitor servers and services, including OpenStack API's health. So like I said, it's open source. There is a dashboard which is provided by Sensu. It's called Yushiwa. I will make a demo at the end of this presentation. And I would like to use the official OpenStack check scripts that are managed by the operational people in OpenStack. Most of the scripts that are in this repository come from the installer that we did at Innovance, the Spinal Stack, and we might want to reuse them in TripleO. The second thing is the centralized logging, which is how to get all the logs and have an overview on what's happening on the OpenStack cloud. So there is three tools for that. The first one is how to collect the logs and how to transform them to a format that we can store and monitor them. So we will use freenode to store the data. This is obviously Elasticsearch and Kibana 3 for the dashboard, which are the most common tools today to do the centralized logging. So what I'm proposing for TripleO is is composed by two iterations. The first stage is do not focus on HA and scaling. I would like to implement the logging and monitoring server on the undercloud. So for that we will install Sensu API, Sensu server, freenode, Elasticsearch, Kibana 3, Redis, and Yushiwa on this node. So obviously there is no HA, there is no scalability feature, so everything is running on a single node. That means that we will have to take care of managing the data and try to purge it every week or every certain amount of days that we will define in the configurations. And the overclocked nodes will be the actual clients of these features, so they will just have Sensu client and freenode that will be installed and send the data to the undercloud. So that's a first stage that is not scalable, that is not HA, that is not really production ready, but it will allow us to get some feedback about the tools that we are going to use. Maybe we will have to iterate by changing some tools because it doesn't fit with what we wanted. But the second stage is to implement some HA and scaling. So that would mean that I think we will create a new node type beside the controller, compute, and storage node. We would have monitoring and logging nodes that will contain the services that scale horizontally, like Elasticsearch and the other services that we can run with the HA proxy to have HA. So that means we will have to investigate whether we create a node separated node on the other cloud or maybe on the other cloud. So that's something we will have to figure out at the second stage. Also, I would like to investigate how to store the external metrics by using maybe Gnocchi and Ceph backends that are the metric service in OpenStack that we already use for Ceilometer, and I think that would make sense to investigate how to store the monitoring metrics from OpenStack directly to Gnocchi. Gnocchi is going to be implemented very soon in TripleO. I'm actually working on this. So the second stage would be maybe a nice opportunity for us to investigate this path. And the last thing that I did not mention in the introduction, but in the second stage, we might want to investigate integrating the performance monitoring by using something like Grafana and CollectD. But that's something that will come after that at the end. So I have a quick demo of the first stage. I have an undercloud running on the left. I wrote a Puppet manifest to deploy OpenStack and to deploy all the tools, all the operational tools. So if you look at the right, there is all Puppet code that will deploy freenode, the plugin for Elasticsearch, the connection between freenode and Elasticsearch, and all the configuration for freenode and how to read OpenStack logs. So if you look at the configuration, this is not intrusive. That means it takes an already existing cluster, it just reads the logs. So you don't change anything in OpenStack configuration. It just reads the logs from varlog, Keystone, Nova, whatever. But it doesn't change anything in the OpenStack configuration. That's something very important for us, that it's not intrusive for the people that are going to use the feature. So my demo is grabbing the logs from Keystone, Nova, Glance, Cinder, or Neutron. That's for the demo, but obviously later we will support all the services that we need. I'm also deploying Kibana, so you can see it's very simple. Just include Kibana and the Puppet module just do the job. We manage Elasticsearch. We have to install Java, but that's dependency of Elasticsearch. And a bit of orchestration to manage the deployment in one single Puppet run. And then we install Sensu. So we have the dashboard, which is Yoshiwa. We configure the Sensu endpoints, and then we say, okay, let's install Sensu server. And I added a couple of checks. The first one is the check NTP, which is taken from the Nagios plugin whole package that you can find anywhere. It's a very common check. It's just to check if the NTP connection works. And the other one is more for OpenStack. It's actually testing if Keystone API is working. So this check is a Python script that is written by the OpenStack community, and that's the script I was mentioning before, the script that comes from Spinal Stack, and that's what we want to use because we already have all the services running supported by the script. Sorry. And that's it. So all this manifest, when you run Puppet on this is what I did at the beginning of the presentation. So you get the node working. So now I'm going to show the dashboard. So there is a Yoshiwa dashboard, which is here. So if I look at the check, we have 2 checks: the check Keystone API, the check NTP. We don't have any events because because all the checks currently work. So if you look at the data center, we have the undercloud server, which is the name of the Sensu data center that I called in the manifest. We have one client which is the undercloud right now, like I said, and if I click on this, we have three checks: the check NTP, the keep alive, which is a basic check, and the check keystone. So the check keystone is having a warning because it's not using OpenStack client, but that's something we are working on, and the script is not failing anyway. That's so if I run the check manually, you can see that it returns okay. So I got a token. So that's basically what we might want to improve in the OpenStack monitoring script. It's to use the OpenStack client. But other than that, the scripts are working, and we can monitor by Yoshiwa all the OpenStack health on the undercloud. The next step is to deploy the overcloud as a client of the undercloud. I'm working on this currently. So this dashboard is Kibana 3. This is a log stash view to show the OpenStack logs. So if you look at what happened during the deployment, you can see a lot of actions in OpenVSwitch, in Neutron, and so on. So we could easily create some views for each OpenStack services and have some fancy dashboards to help operational people to debug when something's wrong. Okay, so this is the end. This is the end of the demo. It was pretty straightforward right now, since I'm working on the stage number 1, which is a proof of concept I wanted to present you. If you have any question, I will be very interested by talking with you on IRC or mailing list, whatever. This is my email, emilien@redhat.com, and thank you for listening. Thank you for being with me today. Have a good day.